All right, everybody. Hope you're having a wonderful day. This week we're going to go through properties of exponents, then properties of logs, and we got a quiz. So today we are just going to focus on the properties of exponents. So I got a big disclaimer here. This is important. So these rules can only be used with like bases. That means the bases are the exact same. You need to know all of these rules to be able to apply them in any situation. And this is another repeating math topic. We have done this before in Algebra 1, so it should be pretty good. So a couple things we need to know. We're going to let A and B be real numbers. We're going to let M and N be rational numbers. So we got the products of powers. So here, I'm going to run through these, and if I miss anything I need to expand on, I will. So product of powers, if I have A to the n power times A to the n power, A is the same base. So we're multiplying things with the same base, we add the exponents. So we're gonna have m plus n. Power of a power, so if I got my powers stacked, I'm multiplying those exponents. So I got a to the m raised to the n power, I'm gonna do m times n. So I'm gonna multiply those. Power of a product, so here I got a times b raised to the n power. So since I have the product being raised to the n power, I can split this up so they each get the exponent. A negative exponent means it goes to the denominator. So if I have a to the negative n power, that's the same thing as saying a to the, or 1 over a to the n power. On the side right here, if I have 1 over a to the negative n power, if it's in the bottom, it's gonna just go to the top. Cool? Zero exponent property. Anything to the 0 power is always 1. That never changes. Quotient of powers, so a to the m divided by a to the n. We're going to subtract these. And same thing, power of a quotient, they each get the exponents to a to the m over b to the m. All right. Let's try to think if I see anything. No, I think we're good. So important things to remember here. If a number or a variable does not have a written exponent, it automatically has an exponent of 1. And anything raised to the 0 power is always 1. And then I also put some tricks down here. I copied over from some nice notes that are prettier. PMA, so power of a power is the product. You're going to multiply and then add. Same for when dividing powers, we subtract. And then negative exponents, you flip them, and you're good to go. So this is a very important sheet. Make sure you have these rules somewhere as we practice these. All right, so let's look at some examples here. So I'm just going to be simplifying here. So I have e to the 6th power times e to the 3rd power. So I have the same base of e. I'm multiplying, so I'm going to add the exponents. So 6 plus 3 is 9. I get e to the 9th power. Here I'm dividing. So numbers, you're going to do the same thing. So I'm going to go ahead and draw my line. 18 divided by 2 is 9. Okay. I really don't need to do that unless I need to. And then 6 and 4, I'm dividing, so I'm going to subtract the exponents. So you end up getting 9 times e to the 2nd power. So numbers you treat normally. So if you're dividing, you divide. If you're multiplying, unless they're a base. And then exponents are what we're looking at here. So 4 times e to the 3x, and all of that is getting raised to the 2nd power. So what I'm going to do is I'm going to distribute the exponent. Since there's no addition or subtraction inside, I can distribute the exponent. If there was addition, we can't do that. So everything gets the 2nd power. So I got 4 to the 2nd power is 16. E, this is a power of a power, so I got 3x times 2. So I got 16e to the 6x. 16e to the 6x. So take your time. Power of a power there, we're going to multiply. All right. There's a couple different ways you can do this. I like to take the simple route. But here you're multiplying, so I add the exponents. So I get e to the 3rd power. You could change the negative and then go from there, but that will make things more complicated. All right, let's look at this one. So I got 4e to the third power, and all of that squared, divided by 8e to the fifth power. So let's go ahead and simplify this first. I'm going to distribute this. So I got 4 to the second power, e to the third to the second power, over 8 times e to the fifth power. So that gives me 16. Power I multiply, so e to the sixth over 8e to the fifth. All right, 16 divided by 8 is 2. And then I subtract, so 6 minus 5 because I'm dividing, so I just get 2e to the first. So my answer here is just 2e. All right, let's come over here to 6. All right, I see a lot of stuff I can do, but I see it's raised to the 0 power. Key rule here, anything to the 0 power is always 1. Please don't forget that. I will always have a complicated one somewhere that is raised to the 0 power, and it's always 1. All right, let's look at a tough one. Let's see what I can do here. So I'm not adding or subtracting up top. So everything is going to get that 4 exponent. So I have 2 to the fourth, m to the negative 1 to the fourth, n to the third to the fourth, cubed, n cubed, n cubed. I guess I can go ahead and add those together. So n cubed times n cubed, I'm going to add those together. So that becomes an n to the sixth. And then let's simplify what I have. And then I can go from there. So I got 2 to the fourth power, 2, 4, 8, 16. Negative 1 times 4 is negative 4. 3 times 4 is 12. All right. And now, since I'm dividing, I'm going to subtract the exponent. So I got 16m, I got negative 4 minus 3, and I got 12 minus 6. So what that gives me here is 16m to the negative 7n to the 6th. And one rule that we'll talk about at the end is you cannot have any negative exponents in your answers. So what I'm going to do here is keep the positive up top and move the negative down to the bottom. So I get 16n to the 6th divided by m to the 7th. And I'll write down the 3 general rules at the very end for you. All right. Number 8. So let's distribute this. And there's just 2 of them. So I got x. Negative 3 times 3 is negative 9. 2 times 3 is 6. And x to the fourth. Remember, this is a 1, so I get y to the fourth. So I went ahead and simplified everything I could at the beginning. So negative 3 times 3 is negative 9. 2 times 3 is 6. 2 doesn't have an exponent. It's by itself, so we're good to go. Just the x to the fourth in the bottom. 3 plus 1 is 4 in the bottom. So I got 1 over 2 as just my numbers here. My x's, I got negative 9 minus 4. My y's, I got 6 minus 4. So I got 1/2. I got x to the negative 13, y to the second. So the only exponent that's positive is y to the second. And then my 2's in the bottom, and my x to the 13 becomes positive because it's in the bottom. So if it's a negative exponent, you can put it in the denominator and it can become positive. If it's already in the denominator, you move it to the top and it becomes positive. All right, last one. So it's raised to the negative 1 exponent. You could distribute that negative 1, or I know that since everything's going to change its signs, I'm going to just go ahead and flip this. If you just flip the fraction, you're good to go, and then simplifying. But just to show you it works, if I distribute that negative, everything's going to get at top and the bottom. I get x to the negative third, y to the negative fourth, over 2 to the negative 1, y to the third. So when I flip-flop everything, that becomes a 2 up top. And then I got an x cubed at the bottom, a y to the fourth, and a y to the third, which is the same thing up here. And then now all I have to do here is combine, so x to the third, y to the seventh. And you're done. All right, last thing I do want to show you is your 3 general rules. So the first thing you always have to do, simplify your coefficients. Make sure my spelling was good. So if I have something like a 21 over 7, x to the 4th, y to the 3rd, you have to simplify that to 3. So that's your first rule, is you got to simplify all your coefficients. Second rule, you cannot have any negative exponents. So if I have something like x to the 5th over y to the negative 3rd, I have to simplify that to that, and we're good to go. And lastly, check for duplicate variables. D-U-P-L-I, wow. D-U-P-L-I-C-A-T-E, there we go. So I can't have duplicate variables. So I can't have x, I can't have y, I can't have z in multiple spots. So those are your 3 general rules. All right. So take what we got here, make sure you don't lose it. If you got questions, let me know. Other than that, you're free to go work on your practice. And we will clean this up, and I will talk to you soon. Hope you have a wonderful day.